Okay, we're on to page 3, and this is 55 to 85, our circuits practice. By the diagram below shows 3 resistors, R1, R2, and R3, connected to a 12-volt battery. It's a series setup, and it has voltmeters, V1, V2, and there's one. There isn't one across 3, but they want to know what the voltage across 3. I'm just going to draw it here very quickly. You have 12 volts. You have a resistor here, and a resistor here. And it says the voltmeter on 1 measures 3 volts. On 2, it measures 4 volts. And the question is, what's 3 going to measure, the potential difference or the voltage across that? Kirchhoff. A 15 ohm resistor connected in parallel with a 30 ohm resistor. What's the equivalent resistance? So in parallel, R total is equal to 1 over R1 plus 1 over R2. We just have 2, so we'll stop there. And it's inverted. So it would be 1/15 plus 1/30 inverted. It's also written without this -1 here. It's written as 1 over RT. But if you invert this side and invert this side, that's where the RT equals that comes from. So this is 2/30. So 3/30. Again, don't forget to invert it, is 10 ohms. And you should recognize every time you're in parallel that when you find the total resistance or the equivalent resistance, it's always going to be less than your smallest resistor. So 10 is definitely less than, I think 15 was what we had there. All right, next question. What is the total resistance of the circuit segment shown in the diagram below? This is number 18. It's a parallel circuit, and there's three 3 ohm resistors. So 1/3 plus 1/3 plus 1/3. Again, inverted is what our equivalent or our total will be. So this is just 1 to the -1, which is 1. So our equivalent is 1 ohm. Our equivalent. Number 19, the circuit diagram below shows 2 resistors connected to a 24 volt source. Potential difference. The picture is in parallel, so there's 24 volts. You have one here and one there. They're both, well, they're not both. One's 4 and one's 6 ohms. You want to know the total resistance. It's 1/4 plus 1/6. Common denominator is 12. So 3/12 plus 2/12, not really clean numbers. 5/12, but remember to invert it. So the answer is 12/5 of an ohm, which I think is 2 2/5 or 2.4 ohms. Obviously use your calculator if you have to. There's no shame in that. Next question is number 20. I'm turning the page. I'm doing 2 pages at once. Diagram below shows 2 resistors connected in parallel across a 6-volt source. Compared to the power dissipated in the 1 ohm resistor. So you have 6 volts. They're just drawn boxes. You have a resistor there and a resistor there. This is your 3 ohm resistor. This is your 1 ohm resistor. It says compare the power dissipated in the 1 ohm resistor to the power dissipated in the 3. So we need to find the power at each of these, called P1 and P3. And the easiest way to do this, there's a whole bunch of equations for power. IV which equation you use is basically which one's the easiest to use. And if you look at this picture, it's a parallel circuit. The first rule we know about parallel is the potential difference is the same throughout. So if it's 6 volts here, it's 6 volts across here and 6 volts across here. So I know the voltage and I know the resistors. So my power here is just 6 volts squared, or 36, divided by 3, which is 12 watts. For this one, the power is 6 squared, or 36, and then we're just using this equation. 36 divided by 1 ohm, or 36 watts. So the power dissipated in the 3 ohm resistor, that's this one, is less. And we could say exactly how much. It's a third less, or 3 times less. So, but less is good enough. All right, 21 says the diagram below shows 2 resistors and 3 ammeters connected to a voltage source. So here's your voltage source, and there's ammeters. This is A3, and they say that's 10 amps. And there's a node or a junction right here, or a break or branch. Redraw these things. This is where A1 is, and this is where A2 is, and they tell you A2 is 4 amps. And this goes back to here. They want to know what's the current in A1. So they want to know the current flowing through this resistor. What is I1, we'll call it. And this is Kirchhoff's, again, we might not have used these words, but Kirchhoff's node rule, or junction rule, or current rule. And basically what it says is the current into a node has to equal the current out of a node. We use this in parallel to say that I total equals I1 plus I2 plus ... Meaning this is I total, all right? It's going into this node. So that's, again, if we rewrite this over here, you have 10 amps going in. What do you have coming out? You have I1 coming out here, and I'm just going to call this one I2 going out over here. So your sum of I1 and I2 has to be 10. I2 is 4, that means I1 has to be 6 amps, which is answer A. 22. 22 says a 20 ohm resistor and a 30 ohm resistor are connected in parallel. An ammeter is connected as shown. So as shown, you have 12 volt power supply. There's your ammeter. There's your 20 ohm resistor. You have, sorry, that was awful. Let me undo that. You have a 30 ohm resistor here. Again, this is, what do we say, 12 volts. And the question is, what's the current reading in this ammeter here? Parallel circuit. 12 volts is your total. That means you have 12 volts across here. 12 volts across here. You don't have to solve the whole circuit. You have V across 1, and you have R1. You want to know I1. So V1 equals I1 R1. 12 volts equals I1 times 20 ohms. So I1 is 12 volts per 20 ohms, which is 0.6 amps, which is answer C. You don't have to solve the whole thing. And last question on this page, I believe, 23. It's a switch within a parallel circuit. So you have 24 volts here. You have an ammeter here. You have R1. Then you have a switch right there, S1 they're calling it. And you have another resistor over here. So this R2 is 12 ohms. R1 is 4 ohms. And let's read the question and see what matters here. If the switch is open, okay, so if this is open in this state right here, current can't flow. Maybe I'll change colors here. Current can't flow through this resistor. There's no way for the current to complete this loop here. It's not a part of the circuit. So it's like this doesn't even exist if this switch is open. So your circuit is just this outer loop here. Your V total is 24. Your R total is 12. It's really just a simple circuit. Your I total is going to be 2 amps. I is equal to V over R. 24 divided by 12 is equal to 2 amps. Okay, so the answer is 2. Just to take it a step further, if you close the switch, there would still be 2 amps here because it's a parallel circuit. Your voltage is 24, right, across this. What would happen, though, is you'd also have 24 volts across this, and with the 4 ohm resistor, I know it's hard to see, I would be 6 amps. So by closing that switch, you would draw still 2 amps, but also an additional 6 amps. This ammeter up here would read 8 amps.